What is a capacitor and how does it work? A capacitor is a device which stores electric charge, and it consists of two parallel conductors, also known as plates. The plates can be of any shape and it is placed next to one another. Note, they never touch. Basically, a capacitor is a device capable of storing energy in the form of an electric charge. Both plates carry the same magnitude of charge Q. The capacitor has two plates, one plate which accumulates positive charges and the other plate which accumulates negative charges. Between the plates there is an insulator known as a dielectric. To summarize, there is a potential difference V which is applied or set up across the two plates and an electric field is produced. Unlike a resistor, a capacitor does not dissipate the energy. Instead, a capacitor stores the energy in the form of an electrostatic field between the plates. Capacitance is the ability of a device to store or hold charge. Prior experiments shows that charge Q is directly proportional to the potential difference V which is applied across the plates of a capacitor. So Q is directly proportional to V. Thus, the capacitance will be represented by capital C, and this is the ratio of the magnitude of the charge Q on either plates of the capacitor to the magnitude of the potential difference V between the plates. Are there any factors which affects the capacitance? Well, there are determining factors which are firstly the geometry of the conductors, for example the area of the plates. Secondly, the relative position of the conductors, for example the distance between the plates. And lastly, the material or medium which separates the conductors, which means the ability of a dielectric to support the electrostatic forces. What is the region between the plates of a capacitor called and what takes place in it? The region between the plates of a capacitor, which is usually filled with electrically insulating material, is called the dielectric. So hence, a dielectric is an insulating material or a very poor conductor of electric current. Some common dielectrics are air, paper, mica, glass, oil, and ceramic. When dielectrics are placed in an electric field, no current flows. So hence, the positive charges within the dielectric are displaced minutely in the direction of the electric field, which goes from positive to negative, and the negative charges are displaced in the opposite direction. Therefore, there is a slight separation of charges known as polarization, which in turn reduces the electric field. Can there be a combination of capacitors in a circuit? Yes, there can be a combination. Sometimes we can even replace the combination with an equivalent capacitor. A single capacitor has the same capacitance as actual combinations. Capacitors can be either in series or in parallel. So firstly, for series connection, a potential difference V is applied across several capacitors which is connected in series. The capacitors have identical charges as each capacitor stores equal charge of Q. And the sum of the potential difference across the capacitors is equal to the applied voltage, or in another term, the total voltage. And the current is the same throughout each. However, for parallel connection, the potential difference across the capacitor is identical, and in this case, the total current splits across the capacitors, and the total charge possessed is equal to the sum of the charges on each individual capacitor. Another example of an application of the capacitor is in flash photography. Even a large capacitor stores only a small amount of energy, but it can release this energy very rapidly, as for example in a flash gun. The charged capacitor in the flash gun, for example, discharges and releases around 1 joule of energy in about 1 millisecond. So this is the power output of about 1 kilowatts. So therefore, the small camera battery cannot produce this power output. That is why it takes about 10 seconds for the battery to recharge the capacitor between photographs. A crucial electrical component in defibrillators is a device called a capacitor. So what is a defibrillator? Defibrillators are devices that restore a normal heartbeat by sending an electric pulse or shock to the heart. Defibrillators need a source of power or current to work. Therefore, defibrillators are easy to transport and they often get their power from batteries. Batteries only produce a continuous low flow of current. Therefore, the defibrillator somehow has to use the continuous flow from the battery to provide a brief high flow of current needed for defibrillation. Hence, a capacitor is used as it stores charges.
The capacitance of a parallel plate capacitor is governed by the equation C equals epsilon A over D, where epsilon is the relative permittivity of the dielectric, A is the area of the plates, and D is the distance between the plates. The energy stored in a capacitor is the definite integral of VdQ from 0 to charge Q. The resultant expression is 1/2 Q squared over C. This is equal to 1/2 CV squared.